Let's be real. In-memory storage would not cut it in production. It could be used for demos or local testing, but once you restart the server, all your stored passkeys are gone, as we saw in the previous video. And to make things worse, Spring Security doesn't give you out-of-the-box support to store passkeys using JPA, as it does with JDBC. So we will build our persistent layer from scratch, wire it to JPA, and make it production ready. So let's dive in. We are picking up exactly where we left in the previous video. At this point, we have the passkey login fully working, but it lives in memory. To enable persistence, we need a couple of dependencies. In our pom.xml file, we are bringing in spring-boot-starter-data-jpa, and since we are using MySQL, we will also add MySQL connector Java. Let's set up our database connection. I'm switching from application.properties to application.yaml. You can stick with .properties file if that's your preference. We will start by setting up spring.datasource.url. I am pointing to JDBC MySQL localhost on port 3306 with the database name Passwordless. And let's add the attribute create database if not exist and set it to true. This way, the database will be created automatically if it doesn't exist. For the username and password, I'm using root for both of them. Then, we will set the driver class name to equal com.mysql.cj.jdbc.driver. Next, we will set the database platform to org.hibernate.dialect.mysql.dialect. And we want Spring to automatically generate our tables, so we will set the hibernate.ddl auto to update. We will also configure the naming strategy by setting the physical strategy to physical naming strategy standard impl to ensure that the table name and column names match exactly what we write in our code. Let's also configure the Spring Security to use a fixed username and password. This way, we don't have to deal with the random password every time we restart the server. We will set the springsecurity.user.name to admin, and for the password, let's make it secure and use 1234. Alright, time to define our entities. We will start by creating a new class under the domain package and call it user. You can think of this as your existing user entity. To map it to JPA, we will annotate it with the entity annotation and table with the name t_user. The reason we are using t_user instead of just user to avoid problems since user is a reserved keyword in some databases. Now, let's go through the fields. We got a private long ID, a private string username, a private string password, and a private string full name. Pretty standard. To support passkeys, we will add one new field, a string, and call it external ID. This acts as a stable reference to link the user with the passkeys. You can name it differently if you want. It's fully under control. Now, let's map the fields. The ID gets the ID annotation and the generated value with strategy generation type.identity. For external ID, we use the @column annotation with the name external_ID. For the full name, we will also use the column annotation with the name full_name. Finally, we will annotate the class with the longbox data annotation to generate boilerplate code like getters, setters, toString, and so on. Let's move on to the more interesting entity, UserPasskey. This class represents a passkey or authenticator tied to a specific user. You could call it something else. The concept is what matters. Same as before, we will annotate the class with the data annotation @entity and also @table with the name t_user_passkey. We will start with the private long ID marked as a primary key using the @id and generated value with strategy generation type.identity. Then we will create a link to our user and we will get back to the mapping in a bit. Next is the private string label, which is just a human-friendly name like Touch ID, Chrome, or anything defined by the user. Then private string credential type, which is almost always public key. It's there just to enforce the format. Then comes one of the most important fields, credential ID. This uniquely identifies the key and used to verify the signature as we explained back in part 1. Next on our list, basically our public key but encrypted using CBOR. Stands for CBOR Object Signature Encryption. Then we got the long signature count, which is the number that tracks how many times the credential has been used. Some hardwares like YubiKeys rely on this one. We also have a boolean UV initialized. This tells us if user verification is enabled like PIN code or fingerprint. Then we define the transports, and it will be a comma-separated strings of the supported transport types like USB, NFC, Bluetooth, or internal sensors. It could have been modeled using a separated table, but we are keeping it simple. Next up, we have two booleans for the backup eligible and backup state. And as the name reflects, they tell us if the passkey can be backed up and the backup state. Then comes the beast, the attestation object. This is a byte array that contains the full attestation, including the key material, authenticator info, and bunch of CBOR fields. Trust me, you don't want to parse this manually. That's why Spring extracts some fields for us. Finally, we got the instant created date and a private instant last used date. Let's wire up our JPA mapping. For the user relationship, we will use the many-to-one annotation with the fetch type .lazy and the join column annotation with the name user_ID. For the rest of the fields, we are mapping them to a snake column names like credential_type, signature_count, and so on. For the attestation object, we will set the column definition to long blob just to be safe, since some of these blobs can be massive. We will also annotate it with the large object annotation. Finally, for the created date and last used date, we will just make sure they are mapped correctly to database column names. To complete the first part of our persistence layer, we need a user repository, which is an interface that extends JPA repository with the user and long. Then, we will do the same for the user passkey by duplicating the user repository and point it to the right entity. And that's it. We have got our database configured and our entities mapped and all key fields in place. That's enough for this session. In the next video, we will integrate the passkeys to use our JPA entities and persist them under the MySQL database. See you there.